Hello guys, hope you will be fine and taking good care of your health. Welcome to this video. Today is our last topic of unit number 8. Then we solve its examples and numericals and exercise, and this is thermal expansion. What is thermal expansion? Most of the substances, solids, liquid and gases. You know that substances are only of three types: solids, liquid and gases. Expand on heating. When you heat any substance, for example solid, liquid or gases, it will be expand after heating. And contract means सूख जाते हैं on cooling. Okay, their thermal expansion and contraction are usually small and are not noticeable. However, these expansions and contractions are important in our daily life. Our next topic is to explain this topic. We take a little bit explanation. The kinetic energy of the molecules of an object depends on its temperature. The molecules of a solid vibrate with larger amplitude at high temperature. Amplitude means the distance between two particles. The maximum distance between two particles is called amplitude. Okay. And its amplitude is very low at low temperature. Thus on heating, the amplitude of vibration of the atoms or molecules of an object increases. They push one another further away as the amplitude of vibration increases. Thermal expansion results an increase in length, breadth and thickness of a substance. And our next topic is linear thermal expansion in solids. It has been observed that solids expand on heating and their expansion is nearly uniform over a wide range of a temperature. Consider a metal rod of length L0, means L original here. At certain temperature T naught, we say T naught. You can also this is O, not 0. This is O. Okay, original temperature. It means original temperature, and we call it T naught. Let its length on heating to a temperature T, its length becomes L. Okay. Now we are discussing its mathematical form. So increase in length of the rod. Increase in length of the rod. Is equal to del L. Is equal to L minus L original, because what is the increase in the length of the rod, that we show by a symbol that is called del. This show that the length is changing, and how we calculate it by subtracting original length from change in length. Okay, increase in temperature will increase in temperature of the rod also be denoted by del T, and that is equal to T minus T original or T naught. It is found that change in length del L of a solid is directly proportional to its original length L naught, and the change in temperature del T, that is that we can write like this: del L directly proportional to the original length and del T. When we remove proportionality constant, you know that we put two things. Number one, equal sign, and second we put constant, and here the constant is alpha. This is not directly proportional, it is alpha. You can write it like this: alpha. Okay, alpha. Now L original del T same. You know that del L is equal to L minus L naught is equal to alpha L naught del T. If I shift L naught on the right side of equal to calculate the change in length, L is equal to minus L become plus L naught plus alpha L naught del T. From here you can see the common is L naught, so I can take now common L naught is equal to, here I get 1 plus alpha del T, okay. And also if you want to calculate the alpha sign, here alpha is the coefficient of linear thermal expansion of the substance. You can calculate it from here, from this equation. Alpha is equal to, here you can see on the left side is del L, and these terms are multiplying with alpha. It will be divided on the left side of equal, and here we get L naught del T, and this is the required form of alpha or coefficient of linear thermal expansion, okay. And now our next topic is volume thermal expansion. The volume of a solid also changes with the change in temperature and is called volume thermal expansion or cubical thermal expansion. Consider a solid of initial volume V naught and certain temperature T naught. On heating the solid at temperature T, let its volume becomes V. Now we calculate its mathematical form. You know that as a previous topic, we first of all we write change in volume of a solid. Change in volume of a solid, that is equal to del V, of course, and that is equal to V minus V naught. Also change in temperature. Now we see change in temperature of a solid, that is equal to, of course, del T. Del denote the change in temperature, and that is equal to T minus T naught, okay. This is original temperature, and this is temperature after increasing. Like linear expansion, the change in volume del V is found to be proportional to its original volume V naught and change in temperature del T. Thus we can write del V is equal to del V proportional to original volume del T, okay. Del V after removing proportionality symbol, we put equal sign, and here proportionality constant is beta, and here V naught del T. You can calculate beta from this equation. Beta is equal to del V over V naught del T, okay. And here beta is the temperature of coefficient of volume expansion. Now if we put the value of del V, that is V minus V naught, V minus V naught is equal to beta V naught del T. If you want to calculate V, we shift V minus V naught on the right side of equal, and here we get V naught beta V naught del T, okay. Now here, here plus. From here we can take common volume, and here we get 1 plus beta del T, that is equal to V. And this is our today topic, and theory topics of chapter number 8 are complete. And in next video, inshallah, we solve example problems or numericals of chapter number 8. Also we solve exercise numerical and exercise also, okay. Allah Hafiz.